Good morning, everyone. Today is Wednesday, April 22nd, and this is the lesson for your Science and English Language Arts integration. So our standards we're continuing to focus on are for science, and then I'll go over the ELA ones when we get there. Each planet in our solar system has a unique characteristic, and I can evaluate the characteristics of planets and relate them to the characteristics of the sun, the moon, and the earth. We're going to talk a little bit more next week about the characteristics of the sun and the moon. So today, at this point, if you haven't already, you're going to stop and open up Brain Pop and watch the video on Earth and the video on Mars. And I'm going to check these off as I finish them, just like I expect you guys to. That'll help you. The videos are 2.5 minutes long. It shouldn't take you more than about 10 minutes to watch the videos and 10 minutes to update your chart, because you're just adding a few ideas to each space. I'm going to go ahead and check that off as well. Then you're going to read the story either by clicking on the link for ReadWorks or by looking at the images that I posted on your daily assignment for how long is one day. And it's 10 images because it's a lot of text features. It's very, very little reading. And that's what we're going to read together. And then you're going to answer your annotated notes and question. And annotated notes just means you pre-read, reading strategies, and after reading strategies. And I don't think your reading should take you more than 10 minutes. Our video will be under 15. And we'll set up your ERQ questions for today as well. All right, and then just remember that I'll set a time on Thursday. I'm going to wait till we get a little bit closer to where we can check in and do a Zoom check-in. I'll have a PowerPoint to share with you about the characteristics of the inner planets, and we'll check your chart and see how it's coming along, and you can add information if you need to. So we're going to find in our packet of notes, we're going to find the one that says Wednesday, and yesterday you should have finished writing your 2 sentences to answer the ERQ. Don't forget, we're going to underline great science words and vocabulary words, and we're going to count our words and make sure we have more than 15. Remember our ERQ rubric. Then you should have written 1 similarity between the text features and 1 difference between the text features in a sentence or 2 using 15 or more words. And so now we've watched our videos, we've added to our chart, and we're looking at how long is one day. Of course, we're going to look at our genre and look at our text features, and then we're going to read and mark some of our key information and look at our thinking question. Now, what can kind of guide you as you're reading is how are days experienced differently on the planets. And do you remember which science word is the word that we think of when we think of a day on a planet? We have 2 R words. Which one means the day on a planet? So hopefully you guys said rotation. So today our reading, and I'm going to get my highlighter out. You're welcome to highlight if you've printed this out as well. Our word we're working on today is the idea of a rotation, or to rotate, which is the length of a day. And we're going to compare all of the days of the planets to what we know, which is the day on an Earth. So looking at your paper, what are our 3 text features we see? And you guys should be really quick at this now. Title. How long is one day on other planets? This one, it has words in it, but I really don't think it's a diagram. What do you think it would be? Yeah, I think an illustration. It's not a photograph because it's not real life. And then we have option 1, a paragraph. Subtitle. Page 2. We're going to go through these really, really quickly because, like I said, they're very, very short. A, this isn't helpful, isn't very helpful. We call this we just said it, an illustration. And then we have, and it even tells you what it is. It's a table. And a table is just, it can also be called a chart. And it lists planets and then it lists the length of their day. The chart continues on the next page. We have another illustration. And then it gives you, on the subheading, it tells you what the next one is going to be. A graph. We know graphs have X and Y axes. Then we have, what's this down here? Caption. To start, make a number line that starts at 0 and goes to the highest number you need to include. The first graph is only going to have Earth, Mars, Jupiter, Saturn, Uranus, and Neptune on it. We'll save Mercury and Venus for later. You'll see why in a minute. The longest day among these planets is 25 hours. That means our number line will go between 1 and 25. Okay, so we're going to flip it over. Another graph. This time they've included the x-axis as well as the, what do we call this axis? Y-axis. We have axis labels. And we have another caption. Label the number line so you remember it represents hours. Write the information the graph will have at the top and along the bottom, and write the names of the planets. And of course, even our graph has a title. All right, so here are the first objects placed on our graph. Again, we have a graph and a caption. Make a dot above the name of the planet next to the number of hours of the day, its day takes. Our graph is coming together. What do we do now? Color in the area below the dot to make a bar graph. So this one right now just has them plotted on there, like we've practiced plotting in math. But you could fill it in with a bar, and then we get a bar graph. Now we can easily see which planet has the longest day, the shortest day, and everything in between. That's much easier than reading a list of numbers, don't you think? All right, our next one is this. What do we call this thing? What's also a graph. It says hours. We have our y-axis. We have another caption. We make a number line, but instead of 1, 2, and 3, we're going to use 1,000, 2,000, 3,000. Now we're going to add, make a number line that goes all the way up to 6,000 along the bottom, right, Mercury and Venus. That's why they couldn't go on the other graph. Look how much bigger this number is than on the other one. The other ones were all down here in the corner. Above Mercury, mark a little dot less than halfway between 1,000 and 2,000. It's not going to be perfect, but that's okay. Now make a dot a little above 6,000 for Venus. All right. So you can see what we were just talking about. Earth would be all the way down here on this graph. And then look how slow Venus is rotating. Okay, we have another graph. We have another caption. Do you think we can include Earth, Mars, Jupiter, Saturn, Uranus, and Neptune on here? Their dots will be so close to 0, it would be hard to tell the difference between them. Graphs work best when the numbers are similar in size, usually with the same number of digits. So because all these are down here in double digits, and these all have 4 digits, the graph really can't be put together. All right, so now we're going to go through, and we've already looked at most of the pieces, so there's very little reading involved. But I am going to have you pause and answer your question, because that's really where your thinking is coming in today. So here we are. 1 day is the time it takes a planet to spin around and make one full rotation. Here on Earth, that takes 24 hours. How long are days on other planets in our solar system? And what is the best way to show the answer to this question? All right, it gave us a great definition of 1 day. Option 1. So the first way the author, this is how they structure their information. The first way they could tell us is by using a paragraph. Let's see what it says. We can write a paragraph about how long the days on the other planets are. And on Mercury, a day lasts 1,408 hours. On Venus, it lasts 5,832 hours. On Earth and Mars, it's very similar. Earth takes 24 hours to complete one spin, and Mars takes 25. The gas giants rotate really fast. Jupiter just takes 10 hours to complete one rotation. Saturn takes 11 hours, and Uranus takes 17 hours. Neptune takes 16. I'm going to put a big star here because we want to make sure we add these ideas to our chart. It was one of the key things they wanted us to learn about. Was that very helpful? That was pretty confusing to me. So another way that the author can structure their story is by giving us the information in a table. So the first way was a paragraph, and the next way is a table. Mercury takes this long, Venus takes this long, Earth takes this long, Mars takes this long. Ooh, I think I'll use this for our chart. Jupiter, Saturn, Uranus, and Neptune. Notice how fast a day is on Jupiter. Notice how slow a day is on Venus. All right. That's a little better. We can look up and down at the numbers. We can compare them more easily. But wouldn't it be nice if we could just see how big those differences are? Let's make a graph. So here's our third strategy. We already looked at our graph. They said to start, we read our captions before, with the y-axis. And then it said add all the planets except for Mercury and Venus. And then we added a dot. And then they added bars. So you can see that Earth and Mars are very, very close. The fastest or quickest day is Jupiter. And then, of course, we came all the way over here to Mercury and Venus. And we had to make a whole nother graph. Now you know how to make a graph, and you can show all kinds of information this way. You can graph the time it takes to get to school each day, the number of pieces of pizza your friends can eat, or how many people like the color blue or green. Go on and get graphing. All right, so the first thing we're going to do is we're going to go back to our question. It says the author conveyed the same information using three formats: a paragraph, a chart or table, and a graph. Evaluate the author's structure. Which structure was most effective or useful, and why? Include at least 3 sentences and use details from the text. So what's our verb? Evaluate. And then what are we evaluating? Author's use of structure. Which one's useful, which one's not, and then how many becauses did we need? 3. Now I don't care if they're all about the paragraph, all about the table or chart, or all about the graph, whichever one you want, but I need which one of those 3 structures was very effective or useful. And you might think they're all useful for different reasons. You might think they're all not useful for different reasons, and that's fine. But I need 3 ideas. Why did they show us the structures in 3 different ways? Why was that useful to us? All right, you're going to pause your videotape here, and you're going to complete your comprehension question, your ARQ question. Don't forget to go back to your chart and add some ideas from your rotation on your chart. All right, I'll see you all tomorrow. Have a great day.